Okay, this is the latest installment in the clock repair. It turned out that it was drawing, would eat batteries in just a day or so, a whole D cell. And it was running a little slow on the highest speed. So I did a couple things. I took a Dremel to the gear that tensions the spring to change the speed. So I could turn it just a little bit higher. You can see there's no battery. And then you can watch the motor turn. So what I did is took I found this DC buck. Look at the name and we'll edit this. Drac people make it. And it's a, it will reduce DC voltage. You can input from 5 to 36 volts and you can dial it down between 1 1/4 to 32. And I've done two things. One, I ran this lamp cord basically, or speaker wire, to the plus and minus of the battery. That is fed by the output of this device, and you have to be sure you've got the plus and minus correct. Now I'm feeding the input side with, I have a million of these wall warts. So I took this one. Which I inherited actually. My dad had a bunch of these too. So it's DC and it's nominally 9 volt, 200 milliamps. So I set it up. I'll plug it back in. That was more than enough to input the device so that I could get 1.5. Okay, here we go. So right now it looks like it's reading 1.44 volts out. And then I dialed the voltage limiter, so you may see a red light flash. That's just telling us that it's trying to draw just a little bit, the clock's trying to draw just a little bit more. I measured the clock at about 6 ohms, realizing those motors and stuff, that's not the best way to figure out. But that does put you at about 1/4 of an amp for 1.5 volts, right? 1.5 divided by 6, 0.25. So I set the, you can have the display off, read output volts. Okay, that's on off. You can have it read output current. So I dialed it down to 0.25, and then I watched the little red light, and it would come on when I finally got it dialed down, because it's measuring what's being drawn. So you can see it, the red light flash sometimes. I kept dialing down the current limiter until I started tripping the current limiter. And I think that's safe. So, of course, because as the battery goes dead, it's going to supply even less current, no matter what you try to do, because the voltage keeps dropping. So here we are reading 0.24 amps. And that's the draw. Remember, the wall wart says it's a 200 milliamp. So I suppose we could take it down to protect that, although I'm not quite sure. Yeah, let's do that. 0.34p. Don't have to figure out what that means. So it's coming in about 14 volts, going out at 1.43. I am going to dial this down to 0.2 for the sake of the wall wart. I don't see why it won't. So I'm at 0.2. So the red light will come on, show that it's limiting current sometimes. I suppose I could dial the voltage down a little bit to cause that to be different. Well, I like it like this, so here's 0.18p, 0.24p. I have not dialed in, read the instructions yet. I'll figure that out. So now it's rotating through stuff. That must be a mode. So 14 in, 1.21 out, it's saying now. So I will turn that up just a smidge. So that's what I think it does to limit current, is it actually limits the voltage. So I think I'll take it back up till I get at least like 1.4 volts. So turn the current limiter up till the volts rise a bit. Let's say 1.4. So, anyway, what's going on, we'll read and tweak, is the clock is now running off this buck converter, again, which knocks down DC voltage from whatever source you got. I'm using this wall wart. And we'll just keep an eye out to make sure it doesn't get super hot. I think it'll be okay by controlling the current, which again, I guess will dial down the volts somewhat. And that will keep the clock running without needing batteries. This thing has other functions too. So there's basically the instructions. We had to assemble the case, and everything seems to be working.